Hello friends, welcome back to Rising Mathematics. In one of our previous videos, we have seen the concept of regulated function in time scale. In this video, we are going to prove a theorem based on this concept. Statement of the theorem is, every regulated function on a compact interval is bounded. We are going to prove this theorem by the method of proof by contradiction. So let us start our proof. We know that every closed interval is always a compact subset of set of real numbers. So let us consider a function f from a closed interval t1, t2 to set of real number which is unbounded. So we have considered here a function f from a compact interval which is unbounded. So this is our assumption. Now since function f is unbounded, for each natural number, say small n, there will exist a number a suffix n from the compact interval t1, t2 with modulus of f of a suffix n is strictly greater than n. Further, we know this theorem. Every sequence in a compact set has a convergent subsequence. So, we are going to apply this theorem in remaining proof. So, if we consider a sequence with general term a suffix n from a compact interval t1, t2, then because of this theorem, we can say that this sequence will have a convergent subsequence with the general term say a suffix n suffix k. Now, as this subsequence is convergent, so it will have a limit point t naught, and from this theorem we can say that this limit point t naught will be again a member of the compact interval t1, t2. We will call this as 1. Further, we know that a time scale is a closed subset of set of real numbers, and as t is closed, so it will contain all its limit point. Now if we consider this, that a subsequence with the general term a suffix n suffix k is from the time scale t, then as t is closed, so limit point of this sequence will be a limit point of t, and therefore t naught will be a member of time scale t. Then from 1, this limit point t naught cannot be isolated, and there exists either a subsequence that tends to t naught from above, or in other words, t naught will be a right dense point in this case, or a subsequence that tends to t naught from below. In this case, we can say that t naught is a left dense point. Now we know that a function f is regulated function if it has finite limit at every right and left dense point in the given time scale. Now here t naught is either a right dense point or a left dense point, so the function ft will have a finite limit as t tends to t naught, because the function f is a regulated function. But this will be a contradiction to the assumption that ft is unbounded. So our assumption that the function f defined from the compact interval t1, t2 to set of real number is unbounded was wrong, and hence the function f defined on a compact interval must be a bounded function, and this completes our proof.